Welcome to this training session on Linux users, groups, and file permissions. In this lecture, we'll start from the foundational concepts of file ownership and permission models in Linux, and gradually move toward more advanced features, specifically access control lists, or ACLs. Whether you're a beginner in system administration or working in more advanced DevOps or cloud environments, understanding permission models is absolutely essential for securing your systems, enforcing least privilege, and ensuring controlled collaboration. Let's get started. In Linux, everything related to access control revolves around users and groups. Every file, every directory, and every running process is tied to a particular user and group. This ensures that the system can always determine who is performing an action and what they're allowed to do. A file in Linux must always have two forms of ownership, a user owner and a group owner. Users represent individual accounts on the system, such as Alice or Bob, and these accounts authenticate into the machine and run processes. Groups, on the other hand, are collections of users. By placing users into groups, the administrator can give shared permissions to multiple people at once. A few fundamental commands help you inspect these identities. ID displays the current user's UID, GID, and all group memberships. Groups lists the groups a user belongs to. getEntGroup retrieves all groups defined on the system, including their members.
Linux uses a simple but powerful permissions model based on three categories: user, owner, group, and others, and three permission types: read, R, view a file or list directory contents; write, W, modify files or delete files inside a directory; execute, X, run executable files or enter or traverse directories. Each permission has a numeric value. Read equals 4, write equals 2, execute equals 1. When you run ls-l, you'll see a permission string such as drwx_r-x-. This means the owner has rwx, which is full access, the group has r-x, read and execute, others have r-, read only. This RWX model is the core of Linux's traditional security system.
Linux provides several key commands for modifying access rights. chmod, used to change permissions. You can use either symbolic notation, like U plus W, or G minus R, or numeric mode, such as 750. Example, chmod 750 file.txt. This sets permissions to rwx-x-. Change owner changes the owner of a file or directory. Examples, change owner, new user, file, or change owner, new user, new group, file. Change group specifically changes the group owner. Example, change group, developers, file. Special permissions. Linux includes three advanced permission bits. Set UID, a program runs with the file owner's privileges. Set GID, runs with the group's privileges. On directories, new files inherit the directory group. And sticky bit prevents users from deleting others' files in shared directories like /temp. These are essential in multi-user environments where controlled behavior is required.
Although the RWX model is powerful, it does have limitations. Single owner constraint. Every file can only have one owner and one group. This isn't flexible for collaboration among multiple users who need different permissions. Lack of granularity. You can't grant customized permissions to individual users within the same group. Broad group access. If a file belongs to the developers group, then every developer gets the same access level, even when only one user needs write access. These limitations become more noticeable in complex environments like shared development servers or departmental shared storage.
To overcome these limitations, Linux provides access control lists, or ACLs. ACLs allow fine-grained control. You can assign permissions to more than one specific user or group on the same file. Additive security. ACLs do not replace the basic model, they extend it. Adaptive access models. ACLs are perfect for collaborative environments where users need different levels of access within the same directory or dataset. ACLs bring flexibility that the default model simply cannot provide.
ACL management revolves around two commands. Getfacl displays the ACL entries of a file or directory. Example, getfacl file name. It shows the owner, the group, and all ACL entries. setfacl-m used to add or modify ACL entries. Example, setfacl-m u://r-secret.txt. This grants user Legolas read-only access. setfacl-x removes an ACL entry. Example, setfacl-x u://Legolas secret.txt. Default ACLs. On directories, you can set default ACLs so that new files inherit permissions automatically. Example, setfacl-d-m g:/path/2/dir. This is especially helpful for shared workspaces.
Let's walk through a common real-world scenario. Step 1. Create and secure the file. Touch secret.txt. chown frodo secret.txt. chmod 600 secret.txt. Now only Frodo can read or write the file. Step 2. Grant additional access using ACL. setfacl -m u.legolas:r-secret.txt. Legolas now has read-only access without altering Frodo's original permissions. Step 3. Verify ACL entries. Getfacl secret.txt. You'll see the owner, group, and the new ACL entry for Legolas. Step 4. Remove the specific permission. setfacl -x u://Legolas secret.txt. The access granted through ACL is now removed. This workflow is exactly how ACLs enhance controlled access without disturbing base permissions.
When working with ACLs, keep a few advanced concepts in mind. The ACL mask. The mask defines the maximum effective permissions for all named users and groups, except the owner. If the mask is restrictive, even generous ACL entries may not take effect. Default ACL inheritance. Directories can have default ACLs, ensuring newly created files automatically follow the correct permission pattern. This is great for collaborative folders. Recursive ACL operations. Using setfacl-r applies changes to all files and subdirectories. This is powerful, but should be used carefully to avoid unintended modifications. Security auditing. Periodically reviewing ACLs is crucial. You can audit ACLs using getfacl-r path. This helps you maintain a secure and predictable access environment.
Let's recap. Basic permissions, user, group, others with RWX are the foundation of Linux security. ACLs extend this model, giving you far more precision and flexibility, especially in shared or enterprise environments. Mastering tools like getfacl and setfacl are essential for modern system administration. The next step is hands-on practice. Try creating files, modifying permissions, applying ACLs, and performing audits to fully understand how these concepts operate in real systems. Thank you for following along. Let's continue with practical exercises to reinforce these concepts.